going to show you in this video a methodology that is really fairly cutting-edge technology. And what that technology is the use of three-dimensional models inside of a web mapping environment. And the web mapping environment that's very compatible with this and freely available and familiar is Google Earth, which we keep coming back to as a very useful, very flexible tool for web mapping. And what I'm going to show you is the process of inserting a three-dimensional model into a Google Earth view that will help with the process of visualization. I want to emphasize very highly that one of the most important aspects of web mapping is the ability to share visualization with a wide clientele. By communicating over the internet, it's possible to share and communicate and help citizens or students or just about anybody can be reached very easily with one of these products to help them see a historical aspect of mapping, a planning aspect, what would our neighborhood look like if this change were made, etc. This is a very, very valuable tool, and again, it emphasizes what I consider one of the key elements of WebGIS, in that it really takes all the power of visualization that can be in a GIS and makes it available easily and widely to any audience. What I'm going to show off is something called the Mackey Building, the model I have here to start with, something called the Mackey Building, which is one of the classroom buildings at Colorado University in Boulder. And a 3D model, often it does come in different formats and different configurations. The core of a 3D model is always something called a .dae file, which is the extension for a file that's in the Collada format, COLLADA. You'll see that on the screen in a moment. This is always the core, and it's a common interoperable 3D graphics, 3D modeling format. This particular model package has a whole bunch of features and colors and textures that enhance the model. Additionally, in this package is a simple KML file which has a geographic location where this model is located in reality. So if I just clicked on this, it would actually zoom to that location and place that model in its actual home in Boulder, Colorado. What I'm going to demonstrate now, though, is that it's possible to just steal the DAE and its optional but often present accessory files and place that model in my own neighborhood to see what it would look like if I picked that building up and moved it to right where I live. So I'm going to go ahead and open up the Google Earth program and get a kind of a default Google Earth application just hovering over North America, and I'm going to go ahead and add this model. And there's a lot of features in Google Earth, and the more I use it, the more I like it. And one of the features is add a model, and I'm first going to specify what location I'd like to be at, and I'm going to write this as 43.290436. I looked this up using pictometry tools earlier. It's just the coordinate of an area near my house, because I'm familiar with it and can show the result a little easier. I'm going to type that in, and I typed it in decimal degrees, 43.290436 degrees. When I hit the enter key, it complains that I haven't specified a model yet. I'll do that. And it also converts to degrees, minutes, and seconds for me automatically to save me the trouble of doing that that is required, that format is required by Google Earth, but it makes the translation automatically, which is really kind of it. The longitude coordinate is 755, 907, and that's a west coordinate, being in the western hemisphere. Hit the key again, it converts it, and it still wants me to name the Collada file, .dae file, that I'm going to insert there. I'm going to go ahead and browse for it on my desktop, and I'm just tracking it down here, the Mackey Building files, and there's the DAE file, and it's as easy as saying enter, and it has now actually placed that building, one of the buildings of the campus of Colorado University. It's placed that model in the middle of that field, which is quite the interesting feat. But now somebody can use whatever they have around Google Earth and scan around my neighborhood, which does show, which is part of the Rochester metro area, and thereby has been gifted with these pseudo 3D models, which are just extrusions with imagery draped over them. But it also has this great big building here, and I think that I could probably pretend I'm in this street and pretend I'm went too close up, and now I can see what the this is a very nice view. I can see what that building would look like from a distance, from the forest off in the distance, and get a good view of this building. And that's really quite the impressive technology, I think. I think you hopefully find that very cool.